going to solve this trig equation over the interval 0 to 2 pi. First thing you want to do is you want to isolate any of the trig functions that you have within the equation. So let's get that sine of x by itself. I'm going to subtract the root 3 over. I'd have 2 sine of x equals negative root 3. At which point, if my goal is to isolate the trig function, I want to divide both sides by 2. So I've got sine of x equals negative root 3 over 2. Now, from here, you've got enough information to figure out what x is. But you may have last year taken this a step further and applied an inverse sign to both sides. Okay, I often look at this as kind of an optional step. Because really, again, you've got enough here to supply you with the answer for x. But if you apply the inverse to both sides, you've got the inverse sign applied to negative root 3 over 2. At which point we're using one of two approaches to figure out x. X is going to equal, if I use the unit circle approach, and I'm making connections here to sine. By definition, sine goes with y, right? That's what we're thinking. So if I am familiar with my unit circle, I'm basically traveling around the unit circle looking for y values that are negative square root of 3 over 2. As I come across those values, whatever radian is associated with that, that's my solution for x. And since my interval up here is restricted from 0 to 2 pi, I'm just making one trip around the circle. So let's think about this. First of all, this is a negative value, right? And we're talking about sine. So if we set up our little all students take calculus idea, sine is positive in the first and the second quadrants, right? So we want solutions from the third and the fourth. Since this is a negative value, we're inserting into the inverse. So in the third and the fourth, we look for y values of negative root 3 over 2. And we should find what? Okay, 4 pi over 3. That would be in the third quadrant. 5 pi over 3. That would be in the fourth. So using the unit circle, as long as you got it memorized or sitting right there in front of you, that's one way to do this. Now, another way to make a connection. I talked about the right triangles, right? Review this idea over here. So if I want to implement that idea, when we're talking about sine, remember our little SOHCAHTOA idea? Sine is opposite over hypotenuse.
Hi.
All right, so if sine is opposite over hypotenuse, what we could do is we could set up a little right triangle over here, or if you're trying to figure out what x is going to be, we could let that be our designated angle. The opposite, well, that's square root of 3, that's this side. Hypotenuse, that's 2, right? If you're trying to figure out what kind of triangle you're working with, you've got to ask yourself what angle here is opposite the square root of 3. Well, that angle would be, according to my special right triangles over here, that angle would be 60, right? So if this angle here is 60, the radian measure that corresponds to 60, well, that'd be pi over 3, right? So if it's pi over 3 and we know we're down in these two quadrants, you take the pi over 3 values from those two quadrants and voila, we're right back here at 4 pi over 3 and 5 pi over 3. So another way to look at it. Either way works. For the second one, let's take the tangent squared of x. Let's subtract 1, set that equal to 0. Very similar to the first one. All these equations that you come across, you want to isolate the trig functions that you're playing with. Here we just have the one trig function of tangent. So I'm going to add the 1 over. leaving me with tangent squared of x equals 1. Trying to get tangent of x by itself, you're going to take the square root of both sides. Now, as you take the square root of both sides, got to remember you're solving here. So plus or minus comes into play. Whoops, squared will cancel. Tangent of x equals plus or minus 1, since that's the square root of 1. So as I talked about in the last one, always view this as kind of an optional step because really you have enough information right here to get you to the answer for x. But x would equal the inverse tangent of plus or minus 1, at which point you could form a ratio here and say, all right, tangent, SOHCAHTOA, that would be opposite over adjacent. I could use a special right triangle to narrow down my search, right? Or you can go back to the fact with the unit circle that tangent has a connection, by definition, to the y values over the x values. So either way, we're trying to get an answer back of 1 if we take y over x, or if we make an association here with the special right triangles. If I use the unit circle approach, I'm trying to squeeze a value of 1 out of this. Basically, the y's and the x's have to be the same thing, right? So where does that happen on the unit circle? That happens at all the pi over 4 stuff, right? You got root 2 over 2, you got root 2 over 2. Now take note of the signs. It's plus or minus. Since it's plus or minus, we are going to cover all 4 quadrants. The tangent can be positive, the tangent can be negative, so all 4 quadrants are covered. That means you have 4 answers here. And if pi over 4 serves as the foundation, we know pi over 4 is one of the answers. That's the first quadrant. The second quadrant would be 3 pi over 4. Third quadrant would be 5 pi over 4. Finally, fourth quadrant would be 7 pi over 4. There are all your possible solutions over the interval 0 to 2 pi. All right, so when you have an example that's got a couple of functions in it, understand that some kind of factoring is going to be involved. So you want to get everything to one side. I'm going to take this sine of x, I'm going to bring it over. You have the sine of x, whoops, times the cosine of x minus the sine of x. All of that equals 0. Got a couple of trig functions, get them to one side so you can do some kind of factoring to separate the ideas. Now that everything is on one side, recognize we have a sine of x present in our 2 terms. We will take that out, and what will be left, now that we've factored that out, is the cosine of x from the first term minus, well, we took the sine of x out here, so 1 from the second term. Had 2 terms to start, need 2 terms here. That equals 0. As we factor and let everything equal 0, we take each factor, we set each factor separately equal to 0. So sine of x is a factor, that equals 0. Cosine of x minus 1, that's a factor, that equals 0. All right, now that we've discussed this on the previous problems, we know we could apply the inverse here, but essentially, we're using a unit circle approach. Sine goes with y. On the unit circle, you're asking yourself where y is 0. So now we're looking at intercepts since a 0 is involved. Y would be 0 here and here, correct? So those 2 key points, the radian values associated with those points would be my starting point over here, which is 0, this point here, which is pi, and then the question becomes, do I include 2 pi as well, because after all, that goes with that point? No, because if you go back to directions, it's 0 to 2 pi, but we're only including 0, not 2 pi, right? So we got 2 solutions so far. Over here on this other equation, you got the cosine of x minus 1. We want to go ahead and move that 1 over, get the cosine of x by itself. And the cosine of x can be connected here to all the x values on the unit circle. We're looking to see where the x values are equal to 1. There's really only one place where that happens, right? Cosine of x equals 1. X would be 1 right here. And that's it. So x would be 0. Since we can't include 2 pi, we have a little overlap here between these two, but really our only answers are 0 and pi, right? X could be 0 or x could be pi. So very similar to the last one, you got 2 trig functions in here. As we discussed in the last one with the 2 trig function, it was nice to move everything to one side so that you could do some kind of factoring, right? But if you look at what you have here and you move, say, the cotangent of x over, are you going to be able to factor anything out? No. No common trig functions. So if you get stuck, what you usually do is you try to use an identity here. And if you recall with cotangent, the cotangent equals cosine of x over sine of x. What's nice about that, if we are interested in doing any kind of factoring here, is that now we have created another cosine. So potentially, if we can get everything on one side here, you know, maybe we could squeeze a cosine of x out and actually do some factoring. Since this is a ratio, normally it's nice to get everything on the same line to play with. We can multiply, since this is an equation, both sides by this denominator sine of x. And we can do that because multiplying that sine of x over, we're not losing the sine of x in the process. So we're not losing any potential answers here for what x could be. We've got the sine of x times the cosine of x. That's going to equal over here the cosine of x. Now this starts to look kind of familiar, doesn't it? Seen that somewhere before. So I turned it into the sine of x, cosine of x equals cosine of x. So I'm going to move the cosine of x over. Let that equal 0. Now I can factor, take cosine of x out. So real similar to the last problem. You got your 2 factors, everything equals 0. You split up the factors. Cosine of x equals 0. Sine of x minus 1 equals 0. Let's go ahead and cut to the chase there. Sine of x is going to equal 1, right? So we go back to our definitions. We use the unit circle approach here, which we really have to because these are intercept values we're dealing with. Cosine goes with x. Sine goes with y. We're asking ourselves, where is x 0 on the unit circle? As we have that little conversation with ourselves, hopefully we answer ourselves correctly and we recognize that x is going to be 0 up here at the y-intercepts, right? So x is going to equal the radian values associated with those y-intercepts. Up here you've got pi over 2. Down here you got 3 pi over 2. There's 2 solutions, right? Chances are we're going to have some overlap over here. Since the y value now is going to be connected to 1, where does y equal 1? Y equals 1 up here. So x is going to equal the radian value there, pi over 2. We could box it in again, but technically we've already included that solution over here. We've got our 2 answers.